We've already done simplifying square roots, correct? For example, if you find this, the square root of 18, what do I do with that? Some of you got relatively poor grades and then you went and switched them because I said I allowed you to because you didn't follow. Really? How do I simplify that, Kyle Westfall?
You put in 2 and 9.
No, yeah, what do we call that? We prime factorize it. Square root of 2 times the square root of 9, and then the square root of 9 is square root of 3 times the square root of 3. And then you look for doubles. 2 square roots of 3 give you a normal 3. This guy here doesn't have a friend, so he stays 3 times the square root of 2. Review? Yes? Well, today they're going... Charlie?
What do you do from 9 to 9? I got the 9.
Well, the 9 got broken down into 3 times 3, so it's irrelevant. Just like the 18. Today, they're really going to do, it's really the same thing, except they're going to do this. They're going to give you something like the square root of 3 times the square root of 12. Where, and here is your thought there, okay? When you have square roots multiplied together, Colton, guess what you can do? Go to check. Right, I can get the square root of 36, but once I get the square root of 36, guess what I have to do? I have to prime factorize it. So, I don't know if this makes sense to you, but just listen. Is there much sense in taking this, then multiplying it, and then breaking it down back really where you came from again, or wouldn't you be just as well to take this, keep it as the square root of 3 because it's already a prime number, and break this one down into the square root of 3 times the square root of, well, 4. And the square root of 4 is the square root of 2 times the square root of 2. Okay. Or you could probably look at the square root of 36 and tell me that there is a square root of 36, which is what, Caroline? 6. 6, which is the same thing you'd get if you did this. 2 square roots of 3 give you a normal 3. 2 square roots of 2 give you a normal 2. And you end up with 6. What I'm saying is, if you're given something to multiply, does it make sense to multiply it and then re-break it down? Why not just start with it is and break them both down all the way and then see if you can simplify it from there? You know what I'm saying? Sam, is that, let me give you one and maybe it'll make more sense. 3 times the square root of 6 times the square root of 15. Now, if I multiply them, I suppose let's just multiply. What do I get if I do multiply that out? Morgan? If I multiply it to 3 times the 1, you get 3, and in the square root sign I get 6 times 15, which is?
That 195.
Good guess. I'm not right, but it's 90.
90.
Okay. Then you're going to have to see if you can simplify the square root of 90. Which, anybody got a real good suggestion for me? Okay. How about the square root of 9 times the square root of 10? Why do I like the square root of 9? Okay, because if you understand that, rather than breaking this down into 2 square roots of 3 and then crossing them off to give you a normal 3, okay, you could have just said, oh, I know the square root of 9 is 3, but that's neither here nor there. Square root of 10 breaks down into the square root of 2 times the square root of 5, but those won't cross off with anything because they don't have any friends or pals or whatever. So you end up remultiplying that back. What do you have for the square root? Square root of 10. What do you have for the number in front? 9. So it's 9 times the square root of 10. Or what if you have the square root of 45 times the square root of 2? Do that for me and tell me what you get. Ava Wyrick, what did we come up with?
3 times the square root of 10.
Oh, not again. How'd you figure that out, Ava?
Well, 2 was already.
You kept the 2 because it was already broken down all the way.
And
45 broke into
9 and 5.
square root of 9 and the square root of 5, and then where'd you go from there?
I turned 9 into 3, and then I multiplied that square root.
There is a square root of 9, that's 3. 5 times 2 back, because that doesn't square 3 times the square root of 10. Kyle Westfall,
I did that anyway. I multiplied.
did you get the right answer?
Yes.
Perfect.
I multiplied 45 times 2.
You got 9 squared root of 90, which is what we just had, and then 9 times 10. There are plenty of ways to do this, whichever way works for you. Now, let's do one extremely difficult problem, and then call it a day. If you look in your book on page 522, which I want you to do,
Wait, what letter?
page 522. Because here is how they're going to have you do some practical application here. The one that says letter E. Find the length of the side of a square with the vertices blah 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 blah. What are the vertices there? Give me one of them. Kendall, what are the vertices? Give me the first one. 5 something?
5, 4.
Wait, we can do that. Here's 5, 4. See if you're with me. I'm in this. This is going to be a square, yes, and then
1, 5.
1, 1, 2, 3, 4, 5.
0, 1.
0, 1.
And 4, 0.
And 1, 2, 3, 4 zeros. Now, that produces a square that looks like this. Now, since it's a square, we know what about it? There we go. I want to find out what the length of one of the sides of the square is. Which means, ladies and gentlemen, kids of all ages, how far is it from here to here, the length of this? And it's not 4. And it's not 5. The only way to figure this out, children, is to use the Pythagorean Theorem, because it's a diagonal line that goes between here and here. So you have to think of some way to make a right triangle that you can find the diagonal of. And let me just tell you that here's one. There's many of them. If you take this triangle right here, by the way, this is why we're talking radicals today, or square roots and stuff. If I make this triangle right here and find its hypotenuse, that's the length of this side of that square. So what are the dimensions of the unfair triangle? Well, this is 1. We know that because we can count up 1. Over it's 1, 2, 3, 4. Now, unfortunately, if I go to my Pythagorean triple thing, there is no 1, 4 triangle. So, unfortunately for all of us involved, we actually have to use the Pythagorean theorem the way it's actually written out. Which is what, Kyle Westfall? What is the Pythagorean theorem?
A squared plus B squared equals C squared.
And which one is A, which one is B, which one is C?
A is the right side.
That doesn't matter. A and B are both the 2 shorter sides.
And then C is the long side.
So let's just make this A is 1 squared, B is 4 squared equals C squared. What do I get when I do the math? 1 plus 16 equals C squared. And we haven't done this for a while, although one class period we spent about 10 minutes doing this. if c squared equals 17, what does the letter c equal? Demetra! Exactly. So this side, c equals the square root of 17. This side right here, even though it's not pretty, is the square root of 17, as would every side be. And the reason why it falls in this lesson here is because they didn't just ask you that side, they also asked you the area of the square. How do I find area of a square? Side times side, which means it's the square root of 17 times the square root of 17. Guess what the area is, Josh?
Square root of 17 squared.
Which, let's simplify that a little bit for the common man. I know that's right where you're at there. Square root of 17 times the square root of 17.
Oh. I know.
Yeah, but only because I so desperately want it to be true. Yes.
17.
It is 17. Congratulations. Why? Because two identical square roots times themselves give you a normal number. It is 17. Square root of, we just did it. The square root of 17 times the square root of 17 is 17. Yes, you could multiply it together and get whatever it is, 149 or whatever it is. But Alex?
Would you still label it cubic square?
But these are square units. Where's cubic come from?
Square.
This is 17 square units. This is just units. Because this is a measure of length. This is area. And if you counted it, it would be 17. So, you won't be afraid and despondent when you come across a problem like that on the assignment.
Wait, so the area is 17?
Area is 17, right. It's a square root of 17, side times side. Each side was the square root of 17. You multiply those two together, they go away. Everybody's